Hello friends, today we take up Davison and Germer experiment. The de Broglie wave hypothesis was verified experimentally by Davison and Germer in 1927. Experimental setup. The setup consisted of an electron gun emitting a stream of electrons, a nickel crystal over which these electrons were made incident, and an electron detector which detected reflected electrons as shown. Now, what were the observations made? A potential difference through which electrons were accelerated used was 54 volt. Lattice spacing of nickel crystal D was equal to 0.914 angstrom, and first order diffraction peak, that is n equal to 1, observed at an angle of 65 degree. Now how calculations were made. Using Bragg's law, 2d sin theta equal to n lambda, wavelength of electron was calculated. Here 2, here d 0.914 angstrom and angle of reflection 65 and n equal to 1, and lambda came out to be 1.65 angstrom. Thus, wavelength of electron was found to be 1.65 angstrom using Bragg's law. Now they verified it using de Broglie wave hypothesis. The wavelength of electron was calculated as follows. Since we know lambda E is equal to 12.27 divided by under root V. V is the potential difference through which electrons were accelerated. And here we substituted the value of V as 54 volt, and lambda E came out to be 1.65 angstrom. Thus, the wavelength of electron as calculated by Davison and Germer using Bragg's law and calculated by using de Broglie wave hypothesis were found to be nearly same. In 1929, Nobel Prize went to Louis de Broglie, and in 1937, Nobel Prize went to Davison and Germer jointly. Now, applications of de Broglie wave hypothesis. An electron microscope is the application of de Broglie wave hypothesis. It was year 1930. Scientist Ernst Ruska developed electron microscope. He used electric and magnetic lenses to focus the beam of electrons. Now, if we look at the resolution of various microscopes, the optical microscope has a resolution of 10 raised to power minus 7 meter. Electron microscope has a resolution of 10 raised to power minus 10 meter, that is 1 angstrom. Therefore, it is good enough to see atoms. Now, principle of electron microscope. Principle of electron microscope is based on de Broglie wave hypothesis. That is, the wavelength of an electron accelerated through a potential difference of V volts is given by the expression lambda equal to 12.27 divided by under root V angstroms. Now, construction of electron microscope. Let's look at construction of electron microscope. Number one, it consists of an electron gun. Number two, accelerating potential difference of the order of 50,000 volts or above were applied for accelerating electrons. Three magnetic lenses were used to focus the electron beam. Magnetic lens 1, magnetic lens 2, magnetic lens 3. As shown in diagram, three magnetic lenses ML1, ML2, ML3 were used to focus electron beam as shown. Now working. Now electrons emitted from hot cathode were accelerated through a potential difference of 50,000 volts or above. The accelerated beam was allowed to pass through magnetic lens 1. And was focused on object. After passing through magnetic lens ML2 and ML3, the final image was brought on a photographic plate as shown in diagram. So thus the electron microscope functioned, and here is the working as I have discussed of the electron microscope. Now, Ernst Ruska shared Nobel Prize in Physics with Gerd Binning and Henrik Rohrer, who were recognized for their design of scanning tunneling microscope. And now assignment 11, question number 25. State the principle of electron microscope, draw label diagram and explain its construction and working. Thank you so much. Thank you so much for listening patiently to me. God bless you. And here we finish with the chapter on dual nature of radiation and matter. Thank you once again.